Hello and welcome to this session. I am Dr. Akshay Kumar from School of Computer and Information Sciences, and in this session I will be discussing with you about matrix multiplication algorithms. Now, multiplication of two matrices technically is a binary operation where we multiply two conformable matrices, okay? And in fact, this particular operation is very useful if you are dealing with linear equations, if you are trying to solve linear equations, if you are doing some coordinate geometry based systems, if you are doing some network modeling. So, multiplication of two matrices is required in those kinds of computations or those kinds of solutions. How do we perform multiplication? Suppose we have two matrices A and B and their dimensions are P cross Q and S cross T respectively. Then conformable matrix which can be multiplied. So, if I represent A multiplied by B, then this particular multiplication will be possible when we are saying that P cross Q matrix is to be multiplied with S cross T. So, Q and S, okay, since we are doing A cross B, right, A multiplied by B, therefore, we are multiplying P cross Q matrix with S cross T. So, what should be similar is that Q should have the same value as S, alright. And if B and A matrices are to be multiplied, if I say B cross A are conformable, it will happen, this kind of multiplication will happen when the value of T, right, because S cross T will be multiplied by with this. So, the value of P should match with T, okay, both should be same. Then only this particular matrix multiplication would be possible, or in other words we call it conformable matrices. The second thing which we are saying here is matrix multiplication is associative in nature. So, if A, B and C are three matrices of order M cross N cross P and P cross Q, then the matrices, if I multiply AB first and then the result of AB I multiplied with C, that is going to be same or equal as if I multiply A with multiplication of B and C, alright. So, if we do the multiplication of that kind. Now, remember one particular thing, when we multiply two matrix, suppose I am multiplying M cross N matrix with N cross P matrix, the resultant matrix is going to be M cross P only, okay. So, when we are multiplying three matrices, M cross N having size of M cross N with N cross P and N P cross N. So, first of all, let us check the conformability. N is matching with N, so that is fine. P is matching with P, P is right. So, it is same. So, the overall, since we have multiplied three matrices, so output of this matrix is going to be of the size M cross Q, okay. So, that is what is going to be the final matrix, okay. And these two matrices are the whatever matrices we will be producing are going to be the same. Now, however, note one particular thing, matrix multiplication is not commutative. For example, if two matrices A and B have dimension M cross N and N cross P, then the matrix AB is equals to BA cannot be defined. It cannot be defined. Why? Because we do not know about P and M, first thing. And second thing, the multiplication, the way of multiplying two matrices will make things very, very different for these two matrices. So, definitely AB is multipliable, but we do not know about whether BA is going to be possible or not, and definitely they may, or mean, the chances that both are similar are not going to, they are not, it is not going to happen. Now, an interesting fact about matrices is that for 3 or more matrices, matrix multiplication is associative, right, that we have already stated, yet the number of scalar multiplication may vary significantly. Now, that is a very interesting fact, okay, depending on how we pair the matrices and their product matrices to get the final product. So, if I am multiplying A, B with first A and B and then multiplying it with C, or I am multiplying B, C first and then multiplying with A being the first matrix, the product of A multiplied by product of B, C, the number of multiplications which would be, and that is the multiplication and additions which will be required for performing this particular multiplication may be very, very different. Okay, and that is why in some later unit we will be doing chain matrix multiplication kind of algorithms. Okay, so from here we will be going on to do something very important dynamic programming stuff which we may do in some other lecture. Okay, now let's look into the matrix multiplication. Okay, so if we have two matrices A and B and we are assuming square matrices, that means they are n cross n matrices, though both the dimensions are the same for the matrix are concerned. Okay, so if I do this particular stuff, so this is my matrix A and this is my matrix B, and the general terms are matrices. Basically the first value represents the row and the second represents the column. So you can see that A11 is first row first column, A12 is first row second column, A13 is third column, like that. This is second row, this is third row. Okay, so is the case with B. So the multiplication of this particular matrices goes like this. So we take, if I want to compute the first element C11, okay, so I'll be taking first row and first column. That's how I'll be getting first row first column of the multiplied matrix. And how we will be multiplying? First row first column. Okay, so this element will be multiplied by B11, A12 of the first row will be multiplied with B21 and A13 will be multiplied by B31. Okay, so this is how it is going to be. Similarly, if I say C21, all right, so this is second row first column. So I'll be doing it for second row first column. So it is going to be A21 multiplied by B11, then A22 multiplied by B21 and then A23 multiplied by B31. Okay, so that is how this particular multiplications proceed, and if the general term can be represented as Cij. So ith term, ith row, jth column, okay, equals, we need Ai. So the row is coming from the first matrix I, and J, B is basically where we are referring to the column, that is where the J is there. Okay, so I and J remains the same throughout this particular case, I mean throughout one row and one column, I mean in one element C12, and what varies is K varies from 1 to n. K varies from 1 to n means with the value of K, that means this value. So if it is 2 1, all right, so we are multiplying C21. So this is the second row and column number 1. So this is going to be what you can see, this is column 1 all the places for B, and row is going to be 2 all the places. And what is varying, if you see this one and this one, so this is the first element, this is second and second element, so K is 2 in this particular case, and K in this particular case is K is 3. So that is how the multiplication of two matrices are taking place. All right. Now, what is the algorithm for multiplication of two matrices? Well, we require input. Obviously, input is going to be the two square matrices A and B, and the size is going to be n cross n. And the product matrix of this is, we are saying the output is the C, and multiplication is, we are giving it an, I mean, it's just taking three values. Okay. So, how does it proceed? We take three indexes I, j and k as we have demonstrated, and I varies from 1 to n. This is for the row, all right. This is for the column, okay, and this is within the columns, okay. So, if we like this row, column, and in it, within the column the value of k is going to vary as we have shown. Okay. So, it is exactly what we have reproduced, whatever the general term was, we have reproduced here. Okay. So, row, column, and then for each of that. Okay. So, row column in this particular case is C11. What is the row we are referring to? First row, first column. All right. C22 we are referring or C21, second row, first column. C32 is third row, second column. So, if we are looking for multiplication of C32, let us say C32, so we are looking for third row and second column. So, multiplication will be k equals to 1, this 2 will be multiplied, k equals to 2, next element will be multiplied, okay. K equals to 3, this particular element is going to be multiplied. All right. So, that is exactly being represented over here. So, we start with C I j equals to 0, whatever row, whatever column we are referring to. Okay. So, that 0 value, and the k value varies from 1 to n. Okay. So, the value of I is not changing. Okay. Only what is changing in this particular loop is the value of k. All right. And the value of j is not changing. Okay. The what is changing is the value k. So, this is how this particular algorithm is going to work. All right. So, suppose I am computing C23, all right. So, the row is second and column is 3. So, the value of k is 1. So, this is 1 in both the places, all right. Then this row is same, you can see, all right, and the column is same, all right, because that column belongs to B, and you are computing C23, and the value of k is changing, k is 1 here, k is 2 here, all right, and k is n in this particular case. So, that is how k varies from 1 to n, and this particular computation is being carried out, and this is how the algorithm or the matrix multiplication, the basic algorithm works. And if I analyze this particular algorithm, this particular loop is going to execute n times. The second loop is also going to execute, since this is executing n times, and for each of that execution, this will be executed n times. So, overall this particular loop will be executed n times, n square times, all right. And for those n square iterations, this particular loop is going to be executed n times more. So, overall we will have around n cube number of iterations, and we will be performing at least one addition in every that particular loop. We will be performing some initialization, and then what we are doing here is multiplication and then addition. So, all these things are requiring constant order time. So, overall this particular matrix multiplication would be order n cube. All right. So, this matrix multiplication algorithm is good. Yes, n cube is the strategic thing. But we are talking about divide and conquer strategy. So, what would be the divide and conquer strategy in case of matrix multiplication? So, smallest, I mean, let's say, what is the smallest 2 by matrix which for division of that further is not going to lead any good results, is basically 2 by 2 matrix. And that is the basis of this divide and conquer strategy. So if we multiply 2 by 2 matrix, so suppose this is matrix A and this is matrix B and this is my matrix C. So how it proceeds? A11 is multiplied by B11, A12 is multiplied by B12 and that becomes my element C11. Alright. What about C12? First row, second column. So it is A11 multiplied by B12, alright, and then A12 multiplied by B21. You can check here. Alright. Now the C21, A2221, it is once again, you can verify this particular situation and you will be getting other elements also. So that's the basis. Over here, there is no looping. And how many multiplication? In total, there are 8 multiplication. You can count. There are 2 multiplication in each iteration and 4 additions. All right. So 4 additions and 8 multiplication, that makes up this particular what divide and conquer strategy. Basically, you are dividing a matrix into this kind of a, or this kind of situation. Now, divide and conquer strategy for multiplication require that we assume the matrices have a dimension of the power 2, like 4 cross 4, 8 cross 8, 16 cross 16 and so on. Alright. Now, power of 2 matrices are easier to divide and that is why we go into and finally we will be reaching to 2 cross 2. And if any matrix is not of the power of 2, then fit in the with zeros to make it power of 2, so that we can divide this particular matrix into A, just like what we did is into 4 kind of a matrices. Okay. Now, divide the matrices into smaller matrices recursively. So, this is the divide strategy. Keep on dividing. If it is 16 by 16, we will divide it to 8 by 8, then 4 by 4 and then 2 by 2. Okay. And finally, it may go to 1 by 1. And conquer will be towards the end we can do the multiplication of 2 by 2 or 1 by 1 depending on whatever the situation may be. Alright. Let's take an example. How does it work? So, this is my matrix. Let's say 2 matrices A as well as B. Now, these are 4 cross 4 matrices and suppose we need to multiply these 4 cross 4 matrices. So, how it is going to proceed? If I say C11, we have just shown C11, C12, C21 and C22. Okay. So, we have basically, if we say, we can divide this particular matrices into 4 parts. All right. So, this is how this division of this particular matrix is going to take place. All right. So, how exactly it is going on? So, suppose I want to compute C11. All right. So, how it is going to take place? A11 with B11, A12 with B21, A13 with B31 and A14 is multiplied by B41. So, this particular row is multiplied with this particular column and we get the results. All right. And the next, once again, the same thing we do for the when we are trying to do C12, we need to C12 is going to be this row, all right, and second column. So, we will be getting B12, that is A11 into B12, A12 with B22, A13 with B32 and A14 with B42. Okay. And so is the case with C21 and C22, except the second row will come into picture and these 2 columns are going to come into picture. Right. So, that is how you will be multiplying these 2 matrices. Look into one particular property. If I divide, what we have done, we have divided the matrix. How we have divided the matrix? This becomes my A11 now. This becomes my second part A12. This becomes my A21 and this becomes A22. So, is the case B11, B21, B21 and B, this is B12 and this is B22. So we are able to divide the matrix into 4 parts. But how the multiplication is going to take place? A11 will be multiplied by B11, okay? But A11 will be multiplied with B21, and when we multiply these two matrices, okay, all these values you can now infer by multiplication. For example, this particular value, you will be getting A1, this second row and first column. So A23 multiplied by B331, okay. Okay, multiply A23, sorry, this is 32, it has to be 32 because it is the second row. Okay, A23 multiplied by B32 multiplied by A24 multiplied by B42, like that. So we are getting these 4 elements, separate elements. Here also we are getting 4 separate elements. All right. So this element, if you see this element, if we combine with this element, we will get C11. So in a nutshell, if I multiply this A11 with B11, A11 with B11, okay, this matrix with this, and this A12 with B21. So what we are effectively doing? We are effectively computing C11, C12, C21 and C22 from these multiplications. So by dividing and conquering, we are conquering now, right? So actually the division, we are just trying to understand first whether we will be able to get the right results or not by this particular division, and whether we will be able to conquer it or not, we will be getting the solutions or not. And what we found that A11 multiplied by B11, this one, plus A12 multiplied by B21 is going to give me this particular matrix. And thus similarly, other kinds of things are also going to fall in place. So I will be getting all the results. So this particular divide and conquer strategy is a workable strategy, and we may proceed with this particular strategy. So how we are going to proceed with this particular, let's look into the pseudocode and try to understand this. So that is number of rows of matrix A, which is once again equal to the number of columns of matrix A, which is once again equal to number of rows and columns of matrix B also, as well as matrix C. And our termination condition is if n equals 1, like just one element is there, we have just one element over there, just multiply these two elements. Else what we are supposed to do? Let Aij and Bij, okay. So we will be breaking that particular matrix. So obviously this is a square matrix now, and square matrix, and it is of the power 2. So it may be 4 cross 4 matrix, 8 by 8 cross matrix, or 16 by 16 cross matrix. All right. So what we are trying to do over here is, okay, so we are dividing it into just 2 parts, okay. In effect, we will be creating 4, okay, and the dimensions of the submatrix. So if we start with 4 cross 4 matrix, we will be creating 4 n by 2 into n by 2, that is 2 cross 2 matrices, as we have seen in that particular case. So we will be creating A11, A12, and we are doing division by 2 only because this is divide and conquer, and we are dividing just to 2 cases because 2 cross 2 is a very good example of division. All right. And B, once again we divide in a similar way, okay. And what you are computing is basically A11 into B11, A12 with B21, this is same, except now capital A and B have replaced. What does they indicate? That these are matrices by itself, okay, and that is what we have shown, right. So these matrices, if we multiply these matrices recursively, ultimately we will be getting our results in this particular situation. So these are like we will be computing C's, all right, and how many computations are there? Like 8 multiplications and 4 additions, all right. And then what we will be returning? C11, C12, C21 and C22, and this basically is a clear-cut replica from a 2 by 2 cross matrix multiplication what we have seen, we now have reached to a recursive definition, and this recursive definition is applicable in all such situations. All right. So, let us look into the analysis of this divide and conquer based matrix multiplication. So, let us go to line 1, okay, line 2, else is obviously not one of the two statements will be executed. Okay, the line 3. Okay, so basically this particular, so these line 4 actually, and line 6. Okay, so 1, 2, 4 and 6. So these are constant times. All right. So these things will happen in constant time. We don't have to worry about that. Okay. However, this is what is going to consume our maximum amount of time. All right. So how many multiplications? 8 multiplications. How many additions? 4 additions. All right. So let's look into that particular thing. So line 5 requires 8 multiplications. Now, please note, we are now multiplying n by 2 matrix with an n by 2 matrix, because we are dividing. All right. But how many multiplications we are performing? 8 multiplications. Right. So, your division is n by 2 as far as size of the problem is concerned, but the number of multiplications which we need to require is 8. So, our recurrence term for this is going to be 8Tn by 2. So, the recurrence term of in this particular case is 8Tn by 2. All right. So, that is how we are getting, because we are multiplying n by 2 matrix with an n by 2 matrix. However, there are 8 multiplication. Now, in addition to that, we have 4 addition operations. Once again, addition operation will be of n by 2 and n by 2 matrix only. All right. Now, what happens when we add 2 matrices, n by 2 matrices? So, addition is going to require n square times, since they are n by 2 matrices. So, n by 2 into n by 2, which becomes n square by 4, and technically the order of this particular thing is order n square only. All right. Therefore, the computing time for Tn for this resulting divide and conquer operation is going to be 8 Tn by 2 and of order plus order n square. So, given this particular recurrence relation, what is the value of A? 8. What is the value of B? 2. So, log of A with base B, log 2 of 8, it is 2 to 8 is 2 to the power 3, right. So, the value of this particular log is going to be 3. All right. And when we check this, and our function was n square, and log A is n to the power log A is n cube. Therefore, the value of epsilon is going to be 1. All right. We have done it so many times. So, you can cross check it whatever I am saying here. Okay. So, value of epsilon is 1, and since this falls into case 1, the complexity of this particular algorithm is theta n, the asymptotic complexity, theta n log of A with the base B, log of A with the base B we have computed to be 3, right. So, the complexity is n cube. Now, it is same as what the matrix multiplication was having, right, the brute force or the common matrix multiplication. So, have we done something better? No, we haven't done anything better, but Strawson's matrix multiplication algorithm reduces. So there were 8 multiplication. Strawson has reduced those to 7 recursive calls or 7 multiplication, right? And few, at the expense of definitely few more additions will be required. However, they will be covered in n by 2 into n by 2 matrices only or additions only. Okay, and this is the Strawson's multiplication algorithm. The important thing is that it is doing just 7 multiplications, and he is doing like he's adding A11 that is element with a matrix with A21 and then multiplying with B11 with B1 B22, just like the other Karatsuba kind of a situation. So some kind of manipulation is being done with some additions and some subtraction. Okay, and towards the end, after performing 7 multiplication, the element C11, C12, C21 and C22 are computed with the help of certain complex operations which involve subtraction as well as addition, because some of the terms will be omitted, some of the terms will be added. Okay, so that Strawson has done this particular research and have found out that these 7 computations will do the stuff. So now if I do with Strawson's algorithm, I have this particular value instead of 8, now it is 7. When it is 7, the value of A is 7, B is 2. So when we go to 2 to the power 7, log B of A is log 7 of base 2, we get 2 to the power 2.81. So our log 27 is basically 2 to the power 81. This is log 27. Okay. So from this particular value, once again we are checking epsilon is greater than 0 and the value of epsilon is 0.81 in this particular case. And what we will be getting, because it is once again case 1 and log 27 happens to be 2.81, therefore the overall complexity of this particular recurrence relation is going to be 2.n to the power 2.81, which is slightly better than n to the power 3. So Strawson algorithm is slightly better than that particular thing. So let us summarize what we have covered in this particular session. That asymptotic time complexity of matrix multiplication algorithm is n cube. Divide and conquer strategy can be used for matrix multiplication. However, it does not improve the runtime complexity. Okay, so the Strawson algorithm, the runtime complexity is 2.81. So it is doing slightly better than that the other algorithms. With this, we come to end of this particular session. Thanks for being with us.